right. Hello, Utah JS. It's so exciting to be here today. Hi, my name is Courtney, and I am a level 99 fire-making wizard. So, I like to create fire. Fire is both destructive and constructive. Fire within me, fire tracks, hot dogs, hot takes, spicy food, sick beats. Why am I so obsessed with fire? Well, all right, so in the summer of 1988, 30% of Yellowstone, known as the Wonderland of the West, was a raging inferno. They had a wet spring and the driest of summers. Due to the climate, high winds, lightning, human effects of wood cutting, dry tinder, it created several wildfires that eventually merged into a singular hellstorm. By the time firefighters were able to control this fire, over 750,000 acres of this national forest was burned. Total construction cost was $3 million. What that means is the world is heating up. Fire seasons are longer, water levels are rising, human populations continues to grow, chances of fires happening increases. So, why does this matter to me, an engineer? Firefighting is what I'll be using to frame my presentation today. So, use imagination, right? Yeah. Okay, stretch with me. So, say you are on a team of 6 people, 1 product manager, 1 architect, 4 engineers. Sounds familiar? Maybe you paid attention to Ethan's talk before this. The group is tasked with fighting fires. Through the power of technology, you get to make a monumental impact on your community, your country, and the world. How would your team fight fires? And more importantly, how would your team effectively measure the effectiveness of the solution? This is not my subject matter expertise, Courtney. I didn't go to school for firefighting. I'm an engineer. Tell me what to build, I'll make the code bulletproof, the UI will feel fantastic, and the program will be performant and fast. Who agrees with this statement? Yeah, there's one honest person who agrees with this statement. This isn't a rhetorical audience participation. Who agrees that why should you care about that? Like, why should you care? It's not your subject matter expertise. You're an engineer, you're a programmer, right? Like, you build code. Do you also own the metrics in addition to how hard programming is, troubleshooting, debugging? Like, who thinks that's not their subject matter expertise and that they have that say at the table about measuring, analyzing metrics? All right, we're getting a couple more people. Yeah, thank you. Way to be, yeah, thank you. Okay, so let's see. Tech companies have migrated. They've gone from, as you can see on the left, functional teams comprised of singular focused professions, multiple teams, right? And then on the right, you see that cross-functional team is comprised of key people equipped with the expertise and ability, capability to drive an objective of said mission to success. Okay. Why do you think tech companies have migrated to become cross-functional? Has this question ever occurred to you before? What was up, you might ask? Maybe it's a budgeting issue. Look at how many more people you need to have a functional pipeline. That's like double X, right? And then, yeah, so maybe it's a budgeting issue, or maybe it's that way by design. Let's go over some of the advantages, shall we? Okay, so let's talk a little bit about waterfall. It's coming back from the spooky past. Yes. So waterfall is a linear process with stages. Bodies of work gets passed from one team. Once that's been fulfilled to maximum completion, it's then handed over to the next team. And then from there, on to the next team, until eventually that gets built. Waterfall provides engineers a specific set of parameters, and the team builds it. So, in this case, develop a powder flame retardant to be carried by jets to reduce fire intensity of at least 7,000 kilowatts an hour and slow fire spread by 10 meters per second. Pretty prescriptive, don't you think? Does it allow for flexibility, for change? I want you all to think about that as we highlight and contrast this specific team dynamic on over to Agile. We're engineers. We don't just settle for one thing. We don't just settle for this is just how we do it, right? We're no one raised their hands besides a couple, 4 people over there. No one believes, like everyone here believes that we are proactive participants in creating and innovating new ideologies. So, again, this is how we're going to contrast the Agile dynamic. So before we get there, the big advantage of waterfall is that there's no extra meetings. There's no debate, not a lot of, people focus on what they do best. Let them handle the rest, right? Product brainstorms, gets the idea into ideation, design, architects makes a blueprint, the dev builds it. Very organized, very clear cut, no room for debate. The decision hierarchy is there. Cool. I see a lot of people listening. That's great. All right. Okay. All right, proactive members of Utah JS, so the Agile way. In my experience, 9 years being a software engineer, this is the only way I've ever lived. I've only heard of spooky stories of waterfall, but sometimes I like to ask, why? Why do we do it this way? What makes it better? So, the Agile way, each team is given an objective. They decide what and how to implement it, and there's not much stopping them other than maybe time, maybe money, maybe technology perhaps, or mostly just time and money. How about we stick with that? So in this case, we're going to make a system that will contain and control fires such that it minimizes destruction and scales for manufacturing. Unlike the waterfall requirement, this is a lot more open-ended, and maybe you like that. Maybe as an engineer you love that. Maybe as an engineer you hate that. And I think that's totally fine. There are advantages to both. There are cons to both. So But what is the biggest advantage of agile approaches? People that are just squashed together, and maybe it feels uncomfortable trying to speak on other people's expertise and add your 2 cents. But hey, that's where I'm at. Maybe that's where you're at also. So, agile teams are autonomous. They share responsibility of the success and failure. It's not like a specific fail point place, like in the pipeline. They own the process end to end, from design, development, and release. All falls on the shoulders of the people in that squad. And the biggest advantages of the agile approach is that it's iterative. Therefore, there's opportunity to change and to make a difference and to pivot. Get creative. Feel good about what you're building. It increases collaboration, promotes creativity, and heck, maybe you even get to learn a couple things along the way from other people. So, this is where we're at. I know most of the reasons people are, the main reason you're in this room right now is, like maybe you read my talk description and you're wondering, how do I become a great engineer? So, first and foremost, this talk is for cross-functional teams. And with that, let me answer the question with a question. If you're a developer or an engineer on a squad and you do all the agile rituals, you accurately and timely break down epics into stories, level of effort is on point, and you conduct your retros, you complete tasks on time. Let me ask you this. Is that enough to make a great engineer? Let me be very plain and simple. The motivation behind cross-functional teams is to break down silos, to encourage collaboration between subject matter experts, to iterate, analyze, make decisions, and to improve outcome together as a team. When I was a new engineer, this was very daunting. I like to just keep my head in the ground, head in the sand, and focus on my task list and to-dos. But then I lost sight of the higher picture, the bigger picture, and did not reflect enough on processes and a team that the only say I had was really like what we should call this variable name. You know what? And I'll say, like, coding is hard. Coding takes time, it takes practice. Doesn't it feel overwhelming to then have to think about the success and failure of your team because maybe we're building the wrong future? What I realized as my experience grew is that cross-functional teams rely on feedback. Engineers won't always know how to fix a bug. To be great, it's to break out of silos, to collaborate with one another, open-minded, open-hearted, iterate, execute, refine, analyze as a team. And together, everyone achieves more. That's what TEAM stands for. Imagine a scenario where there's 2 options. One, you are provided top-down instructions. Oh, actually, hold on. Let me back up a little bit. Two scenarios, but both scenarios, you are being managed by some controllers, fire chiefs, telling you how to best fight this fire. This is what you see. You're in your boots on the ground. You have 4 other firefighters with you. Let's think. Okay. First scenario, You're provided top-down instructions to eliminate the fire. Clear as day, this is the biggest fire outbreak, let's put it out. However, what your team and yourself realize is that it's worse than expected, and it could endanger some of your lives, as well as maybe it's not effective as the fire intensity is too great to manage. So that's the situation. Number two is you relay back up to the controllers what the situation is. They say, hey, they give you feedback on how to get out, and they direct the team to other more productive areas. So which option would you choose? Option two, of course. Through team communication, it saved lives of the crew on the ground and utilized resources in an effective way. Two-way communication led to an optimal solution. It's not feasible any other way. So here's a little joke. What do wildfires and bugs have in common? Just like programming, most fires are caused by humans. All right, here's another one. When the process begins to crumble and a critical bug makes it to production, how should a development team respond? First, fix the bug. Second, create feedback for the team and process. This is often done through postmortems or retrospectives. The team fails together, the team succeeds together. Yeah, let's look at Troy. All he wanted to do was get pizza, darkest timeline. We don't want that. So we're going to talk a little bit about buzzwords in the industry. So what does data-driven mean? Buzzwords. Data-driven is often used in VC startups. It's data-driven. It's just tech jargon for saying we care a lot about ARR. Or, got one person, annual recurring revenue. But I'm just kind of kidding. I'm just kidding, kind of. Data-driven is more than just ARR, let's get it out there. Data-driven teams are teams that coordinate on efforts like KPIs, metrics, and we'll dive into that later on in this presentation, aka next slide. Being data-driven is setting the expectation that every team is responsible for owning the outcome of the features they ship, and it means to set a target. Not only set a target, but actually go back, analyze it, measure the performance, and analyze also means to create a pre-established baseline and measure the before and after and the impact that feature has. Within a squad, a metric you can actually impact. It's called a KPI. So, okay, KPI. Data-driven is to swarm around a specific measurable objective. Do that using KPIs. What's a KPI? They are vital signals for success of company and or objectives. They indicate if the job is being done effectively and it has clear pass-fail analysis. KPI is a specific type of metric. All KPIs are metrics, but not all metrics are KPIs. So they are meant to be measurable, goal-oriented, and relevant to the business. So let's reiterate the problem at the beginning. Your team is tasked with fighting fires and get to utilize the power of technology to make a difference, yada, yada, yada. What does it mean to fight fires? So for us, the scope is to control or contain fire spread, minimize destruction, minimize resources spent, minimize lives lost, minimize reconstruction costs. A tall order. Very, very tall. So given the KPI at the top right here, it means to reduce number of acres burned. Oh, by the way, KPIs, key performance indicators. Oh, okay, so we have leading and lagging indicators. Leading indicators predict the future. They're unstable, so they're they change a bunch, especially if there are things that's not working. For an example, a leading indicator is increased number of firefighters on a scene. So this is a future method, future metric. Future indicator. These are just signals that we can use to measure to correlate to our KPI. Both a leading and lagging indicator rolls up into a key performance indicator, or key performance indicator. So that's leading, and the lagging are indicators in the past that they're easier to create because they're historic. But however, there's downsides to both. This takes a long time to track change. So for example, average burn time over a year. So if our KPI is reduced number of acres burned, what we can hypothesize is by increasing the number of firefighters on a scene, the average burn time over a year decreases. Does that make sense? Like if one or the other changes, it's going to, like if we adjust or fine tune any of these metrics, it's going to ideally roll up and help create a context as to why this KPI is successful or why it fails. And the KPI, you can look at it on its own too, and most often people just look at that, but if you dig deeper, you will know that reduced number of acres burned is surface. And you can tell when that's a pass or fail. So I'm going to just put some examples up here. Please read it. KPIs, these are just to just drive home what a key performance indicator is. You have reduced time for first engine on scene, reduced number of acres burned, reduced number of people-made areas that are destroyed, reduced average burn time, reduced fire intensity. Some of these are KPIs, some of these aren't. So it's a little game. Okay, I don't have too much time, so we're just gonna go ahead and go through this. So reduce time for first engine on scene. Well, this varies per location and it's really difficult to measure success. Reduced number of acres burned, we tracked that, and that is a great KPI because that will help us determine if we're actually controlling the fire. Reduced number of people-made areas that are destroyed. Well, sometimes fires happen in forests and there's no people things. So the specific key term here is people-made. We could certainly track acres burned, which is what we do above. Reduce average burn time. This is a great KPI as well. We want to control the fire, and by doing that, we can eliminate it. The faster we eliminate it, we're doing well. Reduce fire intensity. Key term here is intensity. That's how hot the fire gets. This could be debatable. I will give you that. But we just want to minimize destruction in this case. We go back towards that last slide. We want to minimize destruction. So how do I become a great engineer? And I've added to this, addended. There's on a cross-functional team. Promote alignment on KPIs, metrics, visions. Break out of silos. Collaborate with your team members. Get to know them. We're here for a reason. Iterate. Analyze, refine, and innovate. Understand what the team is tracking and how to influence it. Lastly, let's just go with health metrics really quick. This is not something this is not something critical to track, but it provides context as to why a KPI is passing or failing. It adds context, so it's kind of more plaintive. Can you think, let's see. So we're just gonna look at some examples. So time taken for first engines on scene. This is going to help indicate if our KPI passed or failed. And then time fire was burning before first engine on scene. Again, we're trying to reduce number of acres burned. So this is just helping us get to the problem quicker and solve why we're failing, why we're succeeding. Size of fire before first engine on scene. Some metrics are distracting. These are called vanity metrics. I'm almost done. And so vanity metrics are distracting. So this is honestly like metrics that are published in news articles, the ones that are buzzwords that grab your attention, clickbait, average number of fires per year, number of houses destroyed, number of acres burned, total money spent in reconstruction costs. Notice when I recounted the Yellowstone fire, these were the metrics reported. And my hot take is I'd like to know why metrics surrounding firefighting isn't more transparent or reported. But this is what people paid most attention to. The damaging, the effects, the effects. Small changes, big impact. How you speak, impact how you think, determine how you act. Believe in your squad, go outside your discipline of engineering, help one another, know what a metric is, be clear about it. How you speak impacts how you think, how you act. So KPIs aren't just for project managers, you can also use it for engineering managers as well. Cycle time, perhaps you're familiar. Percent uptime, code coverage. So these are the top 5 habits in summary. Lastly, fires are destructive as fires are, they're also constructive. It reduces competition, clears crowding, brings about change. Sometimes processes don't work. It's easy to get stuck, to coast. Sometimes to bring about change, it takes catalyst. Hopefully not as dramatic as this, but an ignition to propel people beyond their self-imposed limitations and create life in seemingly uninhabitable places. Thank you so much. Follow me on social medias. I think I'm pretty funny sometimes, so.